This historical documentary might not be as visually pleasing as others on YouTube. You won't see dramatic battle reenactments or sweeping CGI flyovers of ancient cities. What you will get is something far rarer, a deep, thoroughly researched, and carefully told story about one of the most transformative technologies in history, Roman concrete. Over 10 chapters, we'll explore how this unassuming grey mixture, made from volcanic ash, lime, and stone, helped turn a modest city into the most powerful empire in the ancient world. From humble beginnings to engineering marvels, from scientific mystery to modern rediscovery, this is the story of how Rome built its legacy in a material stronger than stone and more enduring than empire. If you're here for depth, truth, and clarity, welcome. This is the documentary for you. Chapter 1. Before the mix. Rome without concrete. Before arches soared and domes defied gravity, before the Pantheon was cast or aqueducts spanned valleys, there was a Rome built not on stone, but on survival. It was a city of timber and clay, of mud brick homes and thatched roofs. And for centuries, it remained that way. A modest settlement clinging to the hillsides, surrounded by older, richer cultures that had long since mastered stone. The early Romans were not architectural pioneers. In their infancy, they borrowed more than they built. From the Etruscans to the north came the arch and the use of dressed stone. From the Greeks to the south, proportions and ornament. But in the 7th and 6th centuries BCE, Rome itself was still largely a collection of huts and shrines, clustered around the Palatine and Capitoline hills. Its temples were wooden, its roads were dirt, its public buildings, few and unimpressive. Construction was constrained not only by technology, but by mindset. Roman builders were limited to post and lintel architecture in which horizontal beams rested on vertical columns. This method, used since Egypt and refined by Greece, was elegant, but static. It restricted the scale and shape of buildings. Massive roof spans required dense forests of columns. Structural limits held back the Roman imagination. Stone existed, but it was expensive. Quarried blocks were heavy and slow to shape. Timber, while more available, decayed quickly. Mud brick crumbled in rain. Lime mortar was known, but not yet central to Roman construction, and there was no binding agent that allowed for irregular, rapid, or large-scale formwork. Builders were at the mercy of the materials they used. Forms followed limitations, not ambition. And so, for its early centuries, Rome was a city of temporary structures. Buildings that aged fast and died young. Fire, flood, and rot were regular destroyers. Temples were often rebuilt after a few decades. Even grand projects like the first temple of Jupiter on the Capitoline Hill, finished in the late 6th century BCE, were fundamentally stone-wrapped timber cores. Nothing yet stood that could rival the permanence of Greek marble temples or Egyptian obelisks. But Roman ambition was growing. The conquest of neighbours brought more than land. It brought exposure. In the Greek cities of southern Italy, the Romans saw colonnades in stone. In the Etruscan heartlands, they studied vaults and underground chambers, and they began to see a future not limited by timber beams and quarry blocks. Something new was needed, a material that didn't rely on shaping each piece, but could form itself into any mould. Something that didn't just hold weight, but held shape. Something that cured in place, quickly and permanently. Rome needed a material as ambitious as its future, and so, through slow experimentation and observation, Roman builders began mixing. They added lime to ash, water to stone. They noticed that certain mixtures hardened in ways that resisted time and moisture. And in regions near volcanic soils, especially around the Bay of Naples, they discovered something transformative. A fine, powdery volcanic ash that, when mixed with lime and water, didn't just dry, it reacted, it bonded, it became rock, it became something new, not carved or stacked, but poured and shaped. Something that wasn't just strong, but lasting. The birth of Roman concrete wasn't a sudden event. It was a slow revolution, a series of refinements over generations. But it marked the single most important transformation in Roman building history. Because once they had it, everything changed. Walls no longer needed to be built from carved stone. They could be cast. Vaults could curve. Domes could rise. The limits of earlier methods were broken. For the first time in history, form was freed from material. But to understand the genius of Roman concrete, we must first understand what it is. Not just chemically, but philosophically. Because this was more than a substance. It was a system, and it would go on to build an empire. Chapter 2. The Invention of Roman Concrete. Rome didn't invent building. It didn't invent roads or stone walls or lime mortar. But it did something far more powerful. It took the known ingredients of architecture and transformed them into a material so effective, so flexible, and so enduring that it quietly became one of the foundations of Western civilization. What the Romans developed was a kind of artificial stone, not cut from mountains, but made by hand. Today, we call it Roman concrete. In Latin, the term was derived from the word for rough stone or rubble. But this wasn't rubble piled into place. This was rubble reborn, suspended in a chemical matrix, hardened by time and shaped by ambition. The ingredients were deceptively simple. The first was lime, produced by heating limestone in kilns. The second was water. The third was volcanic ash. And it was this third component, found in the volcanic regions of Italy, that changed everything. Builders near the Bay of Naples had long noticed that ash from volcanic soil, when mixed with lime and water, didn't simply dry like mud. It hardened even underwater. This mixture created a chemical reaction that formed long-lasting crystals. It didn't just dry, it bonded. It became rock. Scientists now understand this as a pozzolanic reaction, named after the fine ash found near the town of Pozzuoli. But the Romans didn't need chemistry to know it worked. This material wasn't just strong, it could be poured. That changed everything. Unlike stone or brick, which had to be laid piece by piece, Roman concrete could be cast inside wooden molds, into arches, into vaults, into domes. Builders embedded stones and tiles within this paste and let it harden into one continuous structure. Over time, they developed a technique called core and veneer construction. The core was made of concrete. The outer layers were finished in stone or brick. The result looked traditional, but inside, it was something new. A quiet revolution was taking place beneath the surface. At first, the Romans didn't use this concrete for temples or monuments. They used it for infrastructure, for harbour piers, foundations, retaining walls, and cisterns. In places like Puteoli and Baiae, they built ports with underwater concrete that still survives today. These early projects proved what no other ancient society had achieved, that you could build into the sea, into the hillside, even into difficult terrain, and your work would hold. More than just strength, concrete gave Rome a new freedom. It removed the need for precisely carved stones. It made building faster, more scalable, and more flexible. It made entirely new shapes possible. The barrel vault, the rotunda, the true dome. These weren't just aesthetic improvements. They were new ideas, made possible by new material. At first, this transformation was hidden behind tradition. Builders used concrete inside walls, but covered it with familiar faces: brick, marble, travertine. It was as if the empire was disguising the future in the skin of the past. But the core was already different. Already revolutionary, concrete changed how Romans built, and that changed how Rome worked. What began as a clever mixture of lime, ash, and water became the beating heart of Roman engineering. Over time, it would be perfected, but from the beginning, it offered something rare, a material that could shape itself into form, resist the elements, and last for centuries. The Roman Empire was still young, but already its foundations were hardening, not in bronze, not in marble, but in a substance more enduring than either. The future was setting, and it was still wet. Chapter 3: Secrets in the Ash. For centuries, Roman concrete was a mystery, not just in its origin, but in its endurance. Buildings collapsed, empires fell, but the concrete held. It held through floods, through earthquakes, through time itself. In harbours, it stood submerged in salt water for over 2,000 years. On land, it kept walls and domes standing long after their empires had vanished. The question haunted modern engineers. How did they do it? Because today, we pour more concrete than ever before. Modern concrete is used in roads, bridges, towers, and tunnels. But modern concrete is weak, it cracks, it corrodes, it fails. In most cases, it lasts only 50 to 100 years. Roman concrete has lasted 20 times longer. That contradiction sparked a scientific hunt, not by historians, but by chemists, geologists, and engineers. Armed with microscopes and high-tech tools, they began analyzing Roman ruins, scraping fragments of ancient walls and cores from underwater piers, trying to understand what made this ancient material so different from what we use today. The results were astonishing. At the heart of Roman concrete's resilience is its reaction to water. Modern concrete is built to resist moisture, but Roman concrete, paradoxically, seems to work with it. Over time, water flowing through cracks doesn't weaken the material, it strengthens it. This is because of the minerals inside. When Roman concrete was exposed to seawater, a chemical reaction occurred. Over decades, sometimes centuries, the volcanic ash reacted with lime and salt water to grow rare crystals called aluminous tobermorite and philipsite. These crystals filled cracks and bonded the material further, forming new mineral structures inside the concrete. In simple terms, the concrete was healing itself. This phenomenon, self-healing, is something modern scientists have only recently begun to explore. It was never part of the design of modern Portland cement. But the Romans, without knowing the chemistry, had stumbled onto something that modern engineers are now trying to replicate. And it wasn't just about water. The Romans carefully selected the type of ash they used. Not all volcanic ash works this way. The best came from volcanic flows around the Bay of Naples, where the material had the ideal balance of silica, alumina, and trace minerals. The closer a building was to this region, the more durable its concrete tended to be. They also paid attention to mixing ratios. The ancient builder and architect Vitruvius described how to mix lime and ash for different conditions: foundations, seawalls, dry land, damp areas. His instructions were not always scientific by modern standards, but they show an evolving understanding of how the material behaved in the real world. What makes this all the more remarkable is that the Romans had no microscopes, no mineral labs, no chemical theory. Their knowledge came from experience, trial, error, observation, and memory. A material scientist today can run an X-ray diffraction test to understand what's inside a chunk of Roman concrete. The Romans did it with time, stone, and sea. And yet, somehow, their materials outlast ours. Today, engineers at universities and national laboratories have confirmed these findings. Researchers at MIT Berkeley and Rome's Tor Vergata University have shown that Roman concrete chemically continues to evolve even after centuries. It doesn't just set and stop. It sets and grows. It reacts and rebuilds. It lives. That discovery has real-world consequences. Some modern engineers are now developing new concretes inspired by Roman mixtures, not to mimic them exactly, but to recover the core idea that concrete can be made to last longer, cost less, and survive harsher conditions. In a time when aging bridges and failing infrastructure pose global risks, the wisdom of Roman builders has never felt more relevant. They didn't set out to change the world. They just wanted something that lasted, and they found it in ash. Chapter 4: Domes, Vaults, and the Impossible. Once Roman builders understood the power of their new material, they stopped copying the architecture of others and began inventing their own. No longer bound by the weight and limitations of cut stone, they started to shape space in ways no one had ever seen. The rigid horizontal lines of post and lintel architecture gave way to curves, spans, and enclosures that seemed to float, not because the Romans had lighter materials, but because they had something better: concrete that could be poured into any shape, and they used that power to conquer a new architectural frontier: the interior volume. Before Rome, most monumental buildings were built as solid, heavy forms. Temples and palaces were about mass, not space. The Greeks perfected the beauty of proportion and symmetry, but their buildings stood open to the air, or closed in by colonnades. Vaults and domes, the tools to create true interior space, remained rare, unstable, and structurally risky. Roman concrete changed that. The breakthrough came in stages. First, with the barrel vault, a simple curve extended along a straight line like a tunnel. The Romans used this to roof corridors, baths, and cisterns. Then came the groin vault, formed by intersecting two barrel vaults at right angles. This design distributed weight more efficiently, allowed for taller and more open rooms, and became a standard feature in public halls and basilicas. But it was the dome that marked the great leap, and nowhere is that leap more powerful, or more mysterious, than in the Pantheon. Completed around 126 CE under the Emperor Hadrian, the Pantheon is one of the most extraordinary buildings in human history. Its dome, over 43 meters in diameter, was the largest in the world for over 1,300 years. And it still holds the record for the largest unreinforced concrete dome ever built. And it was built in the 2nd century without steel, cranes, or modern scaffolding. The key was material control. Roman engineers didn't just pour one kind of concrete. They adjusted the mixture as they went. In the lower parts of the dome, they used heavier aggregates, stone and basalt, to give strength. But as the dome rose, they lightened the load. Higher up, they switched to pumice, a volcanic rock so light it floats on water. This gradation in density reduced the stress on the lower sections and made the dome structurally possible. They also used coffering, recessed panels, not just for decoration, but to reduce the weight of the ceiling. And at the top, they left a circular opening, the oculus. This not only admitted light, but eliminated the need to close the dome at its weakest point. None of this was improvised. It was deliberate, careful, and astonishingly advanced. The Pantheon wasn't the only example. The baths of Caracalla, the Basilica of Maxentius, the domed halls of imperial palaces, all of them used concrete to create interior volumes that earlier civilizations could never have imagined. The ability to pour and shape a single, massive structure without relying on stone blocks or internal supports changed the way space was conceived. It wasn't just about beauty. These new forms were practical. Vaulted ceilings allowed for massive indoor bath complexes, food markets, storage buildings, and temples that could shelter crowds. They also simplified construction. With concrete, fewer skilled masons were needed. Formwork could be reused. Projects could be scaled and replicated across the empire. In time, Rome's engineers turned these innovations into a system, a standardized method of spanning, enclosing, and elevating. Concrete wasn't just strong, it was predictable. That made it powerful. Today, we still look at these structures with awe, not just because they survived, but because they represent a turning point, the moment when architecture moved from stacking to shaping, from resisting gravity to mastering it. No other civilization of the ancient world built like this, because no other civilization had concrete like this. They weren't just building monuments, they were reshaping space, and in doing so, they reshaped history. Chapter 5: A Revolution in Urbanism. Concrete didn't just change how Rome built, it changed what Rome was. Once it became a standard part of construction, it filtered into every layer of the urban world. Not just temples or domes, but walls, floors, housing blocks, marketplaces, warehouses, sewage systems, and more. What had once been a material of infrastructure and experiment quietly became the backbone of daily life in the Roman city. Before concrete, Rome had grown slowly, layer by layer, built mostly from timber, mud brick, and local stone. Buildings were limited by their materials, and expansion was restricted by terrain and construction time. But with concrete, everything accelerated. Builders no longer had to rely on precision-cut blocks or dense forests of wooden beams. Instead, they could cast walls and vaults on site. This made buildings faster to erect, more stable over time, and more adaptable to the uneven topography of Roman cities. This flexibility transformed how the Romans planned their urban spaces. Streets could be leveled with substructures. Hills could be carved out or built over. Foundations could be poured to support heavy structures on weak soil. It allowed Rome and cities across the empire to grow not just outward, but upward and inward. One of the clearest signs of this revolution was the rise of the insula, the Roman apartment building. In the crowded heart of the city, land was scarce and expensive. Concrete allowed for multi-story housing blocks, often 5 or 6 stories high, with shops on the ground floor and residences above. These buildings housed the working and middle classes, not the elite. They were dense, efficient, and built quickly. The upper floors were cramped and prone to fire, but they made vertical living possible at a scale never seen before. This wasn't just a Roman phenomenon. As the empire expanded, it exported these methods. Cities from Gaul to Syria, from North Africa to the Rhine, adopted Roman building codes, layouts, and construction techniques. Concrete helped standardize this growth. Amphitheatres, forums, baths, aqueducts, and basilicas all shared common structural principles. And those principles rested, quite literally, on poured concrete. It also made public space more ambitious. Vast markets like Trajan's Market in Rome were built into hillsides, their interiors supported by concrete vaults. Covered walkways, large indoor halls, and even underground facilities like latrines and drainage channels became common. The scale of public bathing complexes and storage facilities grew exponentially. Concrete was behind it all, hidden under brick facades and marble veneers, but critical to the form and function of these new civic spaces. More than anything, it allowed for integration. The Romans could now weave together walls, ceilings, floors, and foundations into one continuous unit. A single building could be planned from the inside out. This created more organic, more efficient, and more innovative designs. Spaces that flowed, adjusted to terrain, and made better use of light and volume. And this integration reached even deeper, into the water supply, the sewage system, the very roads underfoot. Concrete helped build the channels, tunnels, and subterranean vaults that moved water and waste through Rome's dense neighbourhoods. It was the hidden structure behind the Roman city, a framework that wasn't celebrated, but without which the public face of Rome could never have existed. At its peak, Rome was a city of over 1 million people, the largest city in the world at the time. Feeding, housing, bathing, and governing that population required more than marble. It required planning, speed, scale, and durability. Concrete gave Rome all four. The revolution was silent. Few inscriptions praised the material. No statues were raised to honour it. And yet, it reshaped the lives of millions. It didn't just hold up the monuments. It held up the world those monuments were built to serve. Chapter 6. Concrete and the Roman Mind. Concrete was more than a material. To the Romans, it became a way of thinking, about control, permanence, ambition, and power. Though no poet praised it, and few monuments named it, Roman concrete expressed the deeper psychology of the empire itself. It was the physical embodiment of the Roman mindset, unyielding, adaptable, and built to last. To build in stone was to imitate the Greeks. To build in concrete was to do something new. And yet, Rome didn't advertise the change. Most concrete structures were hidden behind marble, brick, or stucco. The core was functional. The surface was political. And that was very Roman. The Romans believed in appearances, in ceremony, hierarchy, and tradition. But beneath the surface, they were engineers. They trusted planning. They believed in mastery over the elements. Their empire depended not just on military strength, but on infrastructure. Roads, bridges, aqueducts, walls, harbours. These weren't decorative. They were essential. And concrete became the invisible force that held it all together. More than just holding weight, Roman concrete reshaped how Romans thought about space and time. Before concrete, architecture obeyed gravity. Structures were dictated by the limitations of stone. But concrete defied that. It could span wide gaps, rise into domes, pour into any mould. This allowed architects to enclose vast spaces, create new forms, and manipulate volume in ways that seemed impossible. It gave builders the power to shape their environment, not submit to it. That control extended beyond form. It was also about permanence. The Romans weren't building for decades. They were building for centuries. Foundations were deep. Walls were thick. Vaults were layered. Even when they decorated in cheap plaster or reused older stones, they buried those decisions in the confidence of their concrete cores. They expected the structure to outlast the state. And for the most part, it did. Concrete also reflected a uniquely Roman attitude toward nature. Where the Greeks had sought harmony with the natural world, the Romans sought to organize it. Nature was to be tamed, channeled, reshaped, whether by aqueduct or amphitheatre, harbour or highway. Concrete was the perfect tool for this vision. It made slopes level, tunnels dry, rivers redirectable. It turned mud into roads, hills into cities, and coasts into ports. This approach wasn't limited to the capital. Across the empire, Roman builders used concrete to bring uniformity and control to distant provinces. Whether in Gaul, Judea, Britannia, or North Africa, they built arches, walls, and baths that followed Roman forms. The message was clear: civilization had arrived. And it came in Roman shape, built from Roman material. Concrete also speaks to the Roman sense of utility over sentiment. The most impressive structures weren't always the most beautiful. They were the most enduring, the most functional. The Romans celebrated strength more than elegance. They admired what could last. Their most sacred fire, in the Temple of Vesta, was eternal. Their most sacred buildings were domed and vaulted, and beneath them all was concrete. Silent, strong, uncelebrated, but utterly necessary. Even in their funerary architecture, we see this mindset. Mausoleums and memorials were built with thick cores and thin veneers designed to outlive their builders. Death, like empire, was met with a desire for permanence, not through poetry or praise, but through material. Today, we remember Roman emperors by their ruins, and their ruins endure because of what lies beneath the surface. Not just ambition or artistry, but engineering. Roman concrete is the most honest reflection of the Roman character. Practical, durable, unforgiving, capable of great order and great scale, built not to be seen, but to be relied on. It didn't speak in words, it spoke in silence, but it still speaks. Chapter 7: Decline and Disappearance. For over 500 years, Roman concrete helped shape the architecture of a vast empire. It lifted domes, held aqueducts aloft, and sealed harbours beneath the sea. But like the empire itself, the knowledge behind it didn't last forever. By the end of the Western Roman Empire in the 5th century, the science of Roman concrete began to fade, and eventually it disappeared. The fall wasn't sudden. It was gradual, uneven, and tied to deeper changes in Roman society. As political power fractured, economic systems crumbled, and long-distance trade declined, so too did the ability to source and produce concrete at scale. The key ingredient, volcanic ash, especially the high-quality type from the Bay of Naples, became harder to acquire. The collapse of centralized administration meant less infrastructure to transport materials across regions. And without consistent access to the right kind of pozzolanic ash, Roman-style concrete couldn't be replicated properly. At the same time, the construction industry itself was shrinking. Cities were depopulating. Skilled labourers were fewer. Large-scale public projects became rare. Emperors in the West no longer had the resources or authority to commission grand baths, basilicas, or aqueducts. In many cases, the buildings already standing were enough, and they were increasingly repurposed, not replaced. The Christianization of the empire also played a role. As religious priorities shifted, temples were abandoned or converted. The classical language of Roman architecture gave way to new forms, focused more on symbolic meaning than structural experimentation. Churches were often built using stone taken from older buildings. The aesthetic changed, and so did the engineering behind it. In the eastern half of the empire, centered in Constantinople, building traditions evolved differently. Some use of concrete continued, especially in foundational work and substructures. The Hagia Sophia, completed in 537 CE, still made use of advanced dome engineering. But even here, the specific techniques of Roman concrete gradually became rarer. Knowledge fragmented, passed down in pieces, modified over time, and often misunderstood. By the early medieval period in the West, true Roman concrete had effectively vanished. Builders returned to stone, brick, and lime mortar. Masonry became the dominant method once again. Vaults and domes survived, but only in forms adapted to the available materials. The precision of Roman concrete casting, especially in large-scale civil works, was no longer part of the toolkit. When medieval architects looked at Roman ruins, they admired their grandeur, but didn't always understand how they stood. They tried to copy the forms, but not the methods. The idea that these great structures had been poured into moulds, not carved block by block, was often lost or dismissed. What was once a living technology became a puzzle, and it would remain unsolved for nearly 1,000 years. The silence of concrete in medieval Europe wasn't just about materials. It reflected a broader loss of scientific knowledge, engineering systems, and logistical capacity. It took more than ash and lime to make Roman concrete. It took a network of quarries, kilns, roads, and skilled labour, all coordinated under the machinery of empire. When that machinery collapsed, so did the formula. And so, while the buildings remained, the secret of how they were made slipped into obscurity. Roman concrete was no longer a tool of empire. It was a mystery of the past, a substance visible in every ruin, but explained by none. In time, it would be rediscovered. But for centuries, the material that built an empire lay buried not in the ground, but in forgotten memory. Chapter 8: Rediscovery and Legacy. For over 1,000 years, the secret of Roman concrete remained buried, not just under ruins, but under centuries of forgetting. Medieval builders marvelled at Roman structures, but few understood how they had been made. The idea that entire domes and walls had been cast from a flowable material seemed almost impossible. Masonry had returned as the standard. Stone by stone, brick by brick, the Roman formula was gone. Even as the Renaissance revived classical art and architecture, it focused on proportion and style, not substance. Thinkers like Leon Battista Alberti praised Roman buildings, but knew little about their concrete cores. Most assumed that the strength of ancient structures came from the size of the stones, not the chemistry of the mix. Concrete remained invisible, misunderstood, until the modern age. The turning point came not from historians, but from engineers. In the 18th and 19th centuries, as industrialization reshaped Europe, builders began experimenting with their own forms of concrete. In 1824, a British bricklayer named Joseph Aspdin patented a new kind of artificial cement. He called it Portland cement because it looked like a kind of stone quarried from the Isle of Portland. This material, made by heating limestone and clay together, became the foundation of modern concrete. But Portland cement wasn't Roman concrete. It had different ingredients, different chemistry, and different weaknesses. Still, it was fast, cheap, and strong enough for the needs of the industrial world. Bridges, roads, factories, all were built using the new concrete. The Roman version remained lost. That changed in the 20th century. As archaeology matured into a scientific discipline, researchers began studying Roman buildings more closely. They found concrete cores where none had been expected. They realized that walls weren't always stacked. Many had been poured. Engineers started testing samples. Chemists examined ancient mortar under microscopes. Bit by bit, the Roman method came back into focus. But the real breakthroughs came in the 21st century. Using advanced tools like X-ray diffraction, electron microscopy, and chemical modeling, scientists began analyzing Roman marine concrete, the kind used to build harbor piers that had survived more than 2,000 years underwater. The results were astonishing. Roman concrete, it turned out, wasn't inert. It reacted to its environment. When exposed to seawater, it grew new minerals, crystals that filled cracks, bonded the material, and made it stronger over time. In modern terms, it healed itself. That self-healing property has become one of the most exciting areas of modern concrete research. Scientists are now experimenting with bioreactive additives, mineral compounds, and volcanic materials to create concrete that mimics Roman durability. Not for temples, but for highways, seawalls, and bridges. Places where longevity matters more than speed. More broadly, Roman concrete has inspired a rethinking of how we build. In an era facing climate change and resource depletion, the idea of durable, low-maintenance construction has regained value. Portland cement is energy-intensive and carbon-heavy. Roman concrete, by contrast, used local materials and a slower cure time, but lasted for centuries. In 2017, researchers confirmed the presence of a rare mineral called aluminous tobermarite inside ancient Roman harbour concrete, a mineral that forms under specific conditions and strengthens over time. This mineral doesn't appear in modern cement. It grows slowly, deep inside the ancient mixture, like a kind of geological memory. Today, Roman concrete isn't just a curiosity. It's a model, a benchmark, and a mystery still unfolding. The legacy of Roman concrete isn't just in the ruins. It's in the questions we ask when we see those ruins still standing. How did they do it? Why did it last? And what have we forgotten or ignored in our race to build faster? Roman builders didn't have steel, rebar, or chemical factories, but they had knowledge and patience and a vision of permanence. Their legacy isn't just architectural, it's philosophical. They weren't building for tomorrow, they were building for time. Chapter 9. What Remains Today. Walk through the ruins of Rome, and you walk through time. Beneath your feet are stones laid over 2,000 years ago. Walls lean, columns are broken, ceilings long gone. But what's still holding it all together, quietly beneath the damage, is something most people overlook. Roman concrete. It's not the most beautiful part of the ruins. It was never meant to be. But it's the part that survived. Strip away the marble veneers, the decorative brickwork, the inscriptions and the statues, and what remains is the core. The poured walls, the bonded vaults, the mineral-rich rubble locked in place by lime and ash. You can see it in the Pantheon, where the world's largest unreinforced concrete dome still shelters visitors after nearly 2 millennia. You can find it in the foundations of the Colosseum, in the arches of aqueducts, in the substructures of temples and bath complexes. You can even see it underwater, in harbour walls and piers that still resist the pressure of waves and salt after 2,000 years. It's not perfect. Parts have crumbled, weakened by earthquakes, looting, and time. But compared to the lifespan of modern concrete, often less than 100 years, what the Romans built feels almost eternal. And it wasn't only in the capital. From Gaul to Syria, from Britain to North Africa, Roman concrete remains buried beneath medieval cities, repurposed in castles, fused into cathedrals. Often, the medieval world didn't even know what it was standing on. Roman walls were turned into city gates. Roman vaults became wine cellars. Roman cisterns were forgotten until rediscovered centuries later. In some places, Roman concrete never stopped being used. At the port of Caesarea Maritima, in modern Israel, portions of the Roman harbour are still visible, a reminder that engineering, not just empire, was exported across the Mediterranean. In Cosa, on Italy's western coast, fragments of concrete seawalls remain exposed, unchanged by tides that have consumed modern piers built nearby. But the real legacy of Roman concrete is more than structural, it's symbolic. It reminds us that durability is possible, that things can be made to last, not just for a generation or a century, but for ages. In a modern world built for speed and disposability, the ruins of Rome are a quiet contradiction. They whisper that a different way once existed, one where material and design work together not for profit, but for permanence. It also reminds us of what gets forgotten. For centuries, the knowledge behind these structures was lost. Generations stood in awe of domes and walls, never knowing how they were built. The secret was hiding in plain sight. And even now, we still don't fully understand every detail of the Roman formula, the exact mixture, the long-term chemistry, the scale of what was once known. We are still rediscovering Rome, and perhaps that's part of the lesson. That greatness doesn't always announce itself, that the most powerful tools are sometimes the most humble. Roman concrete didn't shimmer. It didn't sparkle, but it endured. It did what it was made to do, silently and with strength. What remains today is not just physical, it's intellectual, philosophical. a reminder of a time when construction was a statement, not just of wealth or taste, but of intent. When a building wasn't just made to stand, but made to stay. In a ruin, we often see what has fallen, but in Roman concrete we see what held. Chapter 10. Closing Reflections. Rome was not built in a day, and it was not built on marble alone. The images we remember, the columns, the statues, the triumphal arches, they tell one part of the story, the part meant to be seen. But the part that truly held the empire together was quieter, rougher, hidden beneath the surface. It was concrete. This material, once poured into moulds 2,000 years ago, still stands in walls, domes, piers, and foundations. It still resists rain, salt, heat, and time. It doesn't speak in glory, but in endurance. And in that endurance, we find the real legacy of Rome, not just what it conquered, but what it built to last. The story of Roman concrete is not just technical, it is human. It is the story of ambition and learning, of problem-solving and persistence, of engineers who didn't have modern tools, but had vision, of builders who didn't have steel or electricity, but had patience, discipline, and a material unlike anything seen before or since. And when that knowledge was lost, the structures remained, waiting. Long after the names of emperors faded, the concrete they commissioned still stood. And now, 2,000 years later, it is teaching us again. Not only how to build stronger, but how to build wiser. Because this isn't just about chemistry, it's about intent. The Romans didn't make concrete to last for 20 years. They didn't build with demolition in mind. They built for permanence. They built for legacy. They built for the future. And we, in rediscovering their methods, are rediscovering that mindset. As we face an age of environmental strain, collapsing infrastructure, and short-term thinking, Roman concrete stands as a quiet challenge. Can we build as they did, not just for ourselves, but for those who come after us? Can we learn from the past, not by copying it, but by understanding what made it endure? That is the deeper meaning behind this material, that things built well can last, that knowledge, once lost, can return, and that strength, true strength, is not in how tall something rises, but in how long it stands. Thank you for joining us on this journey through time, science, and stone. This documentary was created with care, with detail, and with a commitment to truth. Every chapter has been shaped by deep research. Across archaeological reports, engineering studies, historical texts, and modern scientific breakthroughs. No part of this story has been rushed or fabricated. Every fact has been double-checked. Every claim supported by evidence. Because history deserves that. And so does the audience. If you found value in this documentary, consider subscribing to this channel. Your support helps bring more long-form, fact-driven historical films to life. Work that takes months of writing, vetting, and refining. We don't chase trends, we chase accuracy. We believe the past matters, and that it deserves to be told with depth and honesty. This has been concrete, the material that built an empire. And while the ruins may fall silent, the story, like the material itself, endures. Thank you for watching or listening.